Alright, sorry guys, my camera ran out of room, so I had to delete some stuff first. So the first one, we're looking for, I don't know what we got there at the end, but it should be approximately 11 grams for KCl3 at 30 degrees Celsius. Okay? Now the next one, what about at 80 degrees Celsius? So if we come over to 80 degrees Celsius here and move up to KClO3, we're going to hit it right here, okay, which is at approximately, I'm going to say 41 grams, okay? So as you can see, as it gets warmer, you're going to have more dissolving. And that just has to go back to kinetic molecular theory and the collision theory. So as there's more energy, kinetic energy, the molecules are moving, there's going to be more dissociation and dissolving, okay? Now the next one here. What about the solubility of 102 grams? Or what substance has a solubility of 102 grams at 60 degrees? So you go to 60 degrees here, and then I'm going to move up to about 102. And if I look here, that's KNO3. Alright. And then finally, how many moles of NaO3 in 1 liter of water if the solution is saturated at 25 degrees Celsius? So we go to Ka. Let's see here. So we find NaNO3 here on our little graph. 25 degrees Celsius. That's going to put me right about there. So that's 92 grams. I'm going to say 93. So we have 93 grams. 93 grams per 100 milliliters. So, because remember, it's based on 100 grams of water or 100 milliliters. So if we have 100 milliliters, there's 1,000 milliliters in a liter. So we got to do is we got to multiply this by 10. So there's roughly 930 grams in a liter. All right, and we want to know how many moles that's going to be. So if there's 930 grams in a liter, I need to convert the 930 grams into moles. So I divide that by the molar mass. And the molar mass of NaNO3 should be approximately 85. So when I work that out, I'm going to get just a little over, or just a little under, sorry, 11 moles. But seeing how I have 3 sig figs and everything, I have 10.9 moles. Okay, so that's the first part there. Now for the next part here, it says it wants us to describe the solution in terms of saturation for the following. So it wants us to know, if you look up here, if it's going to be unsaturated or supersaturated. So you have to look at the graph. If you're looking at a certain amount and it's below a line, so let's say KNO3 and I'm looking and my amount is below the line, then it's going to be unsaturated. If I'm above the line, that's the line of saturation. That means it's more than saturated. It's supersaturated is the term. Another example of a supersaturated solution would be Diet Coke. If you add Mentos into Diet Coke, it foams a lot. And they say that's because it's supersaturated. It has an overabundance of carbon dioxide. So that's why it bubbles up when you add them.
And sponge.
So if we look here, we're just going to look at a couple atoms. So 70 grams of NaNO3. So here's NaNO3, and we want to look at the temperature of 30 degrees. So 30 degrees. So 30 degrees is here. I go up to 70 grams, and I see that it's below the line for NaNO3. So that's going to be unsaturated. I'm just going to write unsat because it's really confusing to write this with a camera. Then the next one is 60 grams of KCl at 80 degrees. So 80 degrees is here. Find KCl. And it's saturated at 50 and I wanted 60 grams. So I'd say it's supersat. Super sad. Sorry guys. I know my writing's even messier than normal, but it's kind of tough to do this through an iPhone. And then finally 80 grams of KNO3 at 50 milliliter or 50 degrees Celsius. So 50 and go up to KNO3 and it's at 80. So you know what? It's right on the line. Give or take a little bit. So I'm going to say that this is just saturated. Okay? Because it's right on the line, so it should be dissolved. Alright? So not more couldn't be, but more or less couldn't be also. So we just say saturated if it's on the line. Okay? And then the last part here was the solubility tables. The solubility tables we actually used in Chem 20. And it has all the lists of like different ions. Like you'll have chlorides. And if you compare it to like silver, lead, mercury, or copper, it'll have low solubility, meaning a precipitate will form. But if chloride bonds with anything else, all others, it's gonna be soluble, so no precipitate will form. Okay, and we went through this before, and so you have to remember how to use this chart. Okay, so if we were to look at, I'm just gonna do the bottom example here. So PbIl or PbI2. So the ions there would be lead 2 and iodine. So if we look here, would iodine form a precipitate with lead? So if we find iodine, here it is on the chart, okay, just to give you some reference. So there's iodine. Now we compare it to, there's lead, lead 2. Okay, those charges matter. If it was lead 3, it wouldn't form. So see here how it's lead plus 2? Hopefully the camera zooms in. But that's a 2. Take my word, look at your sheet. If it was lead 3, it wouldn't form. The rule wouldn't count. But because it's lead 2, it does count, so we look over. That's low solubility. So that means we got low solubility. That means we're going to get a precipitate. Okay? So that's what those are all about when using the chart. Alright, good luck.